Hi everyone, my name's Craig. Can you guys all hear me all sweet? Sweet, okay. Yep, so I've written a bunch of stuff for coordinates and open source stuff that involves metaclasses, and I think they're really awesome, and I think they're really powerful and useful things that we have in Python, and we should use them. And I don't think a lot of people do use them regularly, from what I've gathered. So I thought maybe I could just introduce you guys to them if you haven't seen them before, or maybe provide a little more background if you have. Maybe make them a little bit more comfortable so that people could, get involved with metaclasses. So you might have seen this before. I don't know if you guys have used Django. I use it every day. But hopefully this is reasonably understandable. You want to create a form in a web page, and Django does it like this. You make a little class called login form, and you give it a couple of fields. This one's a pretty simple form, just has two fields, username and password, and they're character fields. And so that's how you do it in Django. You class login form, inherits from form, and it has two fields. Pretty standard. What we could do then is we might inspect the login form's dict under dict. Now you might expect that a login form's dict would have two things in it, a username and a password. It doesn't actually. It's got this thing called a base fields. And that's a little odd. We didn't really expect that. We didn't create anything called base fields. We created two fields, username and password. So where did that come from? I find that a bit weird. Let's dig into that a bit further. So just a little refresher on classes. Every object has a type, and that type is a class. So the word type is, in Python, it's synonymous with class. We use them interchangeably. They mean the same thing. You don't need to, there's no difference between type and class in Python. And with that in mind, I think it's a bit silly to use the word class because it doesn't really describe what it is. It's a type of an object. So I reckon class is a dumb word, but that's my opinion. But I'm going to use them interchangeably in this talk. A type is a class is a type. They're the same thing. So here's a class. It's a boring class. It doesn't really do much. It inherits from object, and it doesn't do anything. It's called a car. So my snazzy Jaguar, which I don't have, but I wish I did, is an instance of car. So what's the type of my Jaguar? Who wants to guess? What's the type of Jaguar? Car? Someone said it. Cool. It's car. Yep. What's the type of car? Sorry? Type? Someone said type? Yep. What? What is type? What's the type of type? Type. Someone said type? Okay, the type of type is type. Don't think about this too hard or your brains will fall out your ears. But I'm interested in this. We've got this thing called a car, which is a type, but it itself has a type, which is type. And I find that a little bit odd, but it sounds like we could maybe use that for something. So what is type? Well, it turns out that type is something called a metaclass. A metaclass is just, well, by definition, it's just the type of a type. It's the class that a class has. And so when you create a class by using a class statement, what you're actually doing is you're creating an instance of a metaclass. A class is an instance of a metaclass. So we'll just dig into that a bit. Here's a class statement. It creates a class called car. But if you were to not use a class statement to do this, you could do the exact same thing with this thing. You could actually call type, pass it a name, some bases, and some attributes, and you'd end up with a class. So these two these two things here are exactly the same, and you can use them interchangeably in Python. So what happens if we subclass type? Well, I'm going to go back to our form example. This is a slightly simplified example based on what Django is actually doing behind the scenes when we create a form. You might note that when we called type there, we're actually instantiating a type. So this is no different than if you instantiated a car. So you're calling a class, you're passing it some arguments, and it returns an instance of the class. Only the difference is here, the class is actually a metaclass, and it returns an instance of the metaclass, which is a class. So there's nothing magic going on here. So what we can do is just define a new method on a metaclass. It takes some arguments, the same 3 arguments that we just passed it, name, bases, and attributes. And it returns a new instance of that metaclass, which is actually a class. So this is a little involved, obviously, but there's, again, nothing magic going on here. This is exactly the same way that you create an object in Python, only we're using it to create a type. So this is what Django's doing. It's basically looping through the attributes you give it, checking if they're fields. If they are fields, it's adding them to a thing called base fields, and then it's returning a new instance of the metaclass with the new attributes. So when the form class, base form class is created, all we're doing is telling it that it's going to use this metaclass. And so behind the scenes, this is doing exactly the same as we used to create our car class. It's basically just calling the metaclass, passing it a name, bases, and attributes. And that will create a class called form. So then if we want to create our login form, all we have to do is subclass form. It inherits the metaclass from the form. That's important because that means that when we create login form, it's going to call form metaclass instead of type. And it's going to pass it a name, some bases, and some attributes. So that's the Django magic explained. It's really very simple. Sorry if it didn't look that simple. So there's lots of good ways to use this. What you see on the screen here is an example of a design pattern called the Registry Pattern. You've probably seen it before if you've used classes in Python for very long. Basically, what's happening is you have some data which might come in various forms, and each form needs processing in a slightly different way. And so to handle each type of data, you register a handler for that data, something like that. So we've got an XML handler here, which basically just tells you to go away because XML is horrible. We've got a JSON handler, which handles JSON by calling loads on it. And we're just registering those handlers against the MIME types, text, XML, and application JSON. That's all very well. It's kind of ugly. The problem I have with this is that if you forget to call register handler after you've defined your class, nothing will happen. Your handler will never be called. And it's easy to forget. So you can spend ages writing your awesome handler, and it will never be used because you didn't call register handler. And it's not immediately obvious by looking at the class that actually to make the class do anything, you need to call this extra function below it, or you need to decorate it with something or something. So registries are they're not too bad, but they're annoying. And I thought it would be cool if we could do something like this instead. Basically, on the class itself, we're defining the MIME types that it accepts. And that's cool, except I'm not really sure where it's doing that registration. It's obviously got to register itself at some point. And of course, the answer is metaclasses. yeah, this is slightly prettier. The accepts is up the top where it belongs. It's an important thing about the class. It doesn't belong right down the bottom. And I know you can fix that with decorators, but we'll ignore that. And it's good in that we can guarantee if you don't put an accepts thing on your class, we can throw an error. So you can't forget to do it. It doesn't silently fail. So this is kind of nice. How are we going to do this? Well, let's create a handler metaclass. I like fixing things with metaclasses. It makes me happy. I'll step through what this is doing because it's a little complicated. The first thing it's doing, so a metaclass creates an instance of a metaclass, which is itself a class. So what we're doing here is creating a handler class. So we're either creating handler or we're creating a subclass of handler. So again, we've got our new method. It takes name bases and attributes. And the first thing it does is actually just create the class, because it calls the superclass of my handler metaclass. So we've already created the class at the start of this. But then we want to register that class against something. So the next thing I do is I just check if I'm actually creating handler, because if I am, I don't really need to do much. I don't need to register handler itself. It's the base class. So if handler doesn't exist yet, then I guess I'm creating handler, basically. And so all I do is create an empty registry that I can register the other ones against and return it. With me so far? Cool. Right. But if I'm not creating handler, because handler already exists, then I must be creating a subclass of handler. Because remember, classes inherit their superclasses, metaclasses. So I'm getting called to create a subclass of handler, maybe JSON handler or something. So I just want to loop through what's in the accept. It'll be text XML or application JSON or something, and stick it in the registry along with that class that I just created. So now I've basically just stuck my register function into this metaclass. And that's it. So we've done away with registries. We've got this nice little accept attribute, and that's cool. That is a little confusing, but the point I want to make here is that you actually only need to do that once. So when you create 100,000 handlers, all that registry code is done away with. It's already done. It's in the metaclass, and you'll never see it again. You don't have to think about it. It's just kind of done for you. So that's a lot of overhead if you're only registering 2 handlers. But if you're registering a lot of things, or if there's a lot of code involved in registering or something, then it's nice to put that where it belongs in a metaclass. So let's go on to something more complicated. I know Graham Dumpleton is giving a talk on decorators tomorrow, so I'm hopefully not going to step on his toes too much. That'll be a really interesting talk. I'm looking forward to seeing it. I'm not going to go into how decorators work. Well, I'm going to try not to too much. But I wrote a cool little app that uses metaclasses to make decorators nicer. So I thought I could just show you as a good sort of example of awesome metaclasses. So here's some decorators. Actually, there's one decorator here, the top one. Who's used a decorator before? Okay. Who's written a decorator before? About the same number of hands, okay? It's kind of interesting. Basically, what a decorator does is it's a function that takes a function as an argument and returns potentially another function. So it decorates the function it's given and returns a decorated version of that function usually. I'll just skip forward a slide so I can show you basically that crazy symbol syntax there is, it was introduced in Python 2.3, I think, somewhere ages ago. But basically what you're doing is you're actually just calling debug function with your function, and it returns a function which you assign back to the original function name. So you're overwriting myfunc with a decorated version of myfunc. Does it make sense? So Usually we just use the @ syntax, but just to show you what that it's actually doing, I just thought I'd put the old school way of doing it there. Now this crazy thing down the bottom is what's called a decorator factory. And the term decorator and decorator factory are often used interchangeably, but they're completely different things. And you get confused if you get them confused. A decorator factory is a function that returns a decorator. Okay. So it's a function that returns a decorator, which itself takes a function and returns a function. Who's still with me? Okay. Now that's confusing, but we can use it to do things like this. To say pass arguments to our decorator, something like that. So we're calling this thing, we're giving it this output to argument, and we're creating a decorator which knows about that output to. So I'd probably expect this, because of the way it's named, to like print out some output when we call the function we're decorating, right? And it will print it out to that output to thing. So yeah, I assume that's how it works. So this function does do both. It can be called as either a decorator or a decorator factory. Yeah, so who's written something like this that can, yeah? Okay, well done. It's kind of confusing. I've got this slide up here as more of the way not to do it rather than the way to do it. We've got several levels of things happening here. The first thing we're doing is we're defining a decorator. And then we're checking whether we're being called as a decorator factory or not. If we're being called as a decorator and not a decorator factory, then we'd expect the argument we're given to be a function. And hence, this code path here deals with the decorator side of things, and basically just swaps the function and the output to thing, because it's not actually output to, it's the function we're decorating. And so we set output to the value we want to be the default value, and then return the decorated function by calling our decorator, and that's nasty. And then the other code path is if we're not being called as a decorator, we're being called as a decorator factory, we're going to return our decorator and not call the decorator just yet. Then the decorator will get called with the function it's decorating and return a wrapped function which does some outputty things. That's horrible. So I thought we could do it better than that. I thought maybe we could do it like this. This was a bit of a pipe dream. I thought this is a long way from that horrible mess. Maybe I could do it like this. I just want you to note that I'm trying here to solve both cases, the decorator and the decorator function. So if we look at that, there's actually two setup steps here before our function gets called. We're defining a decorator, and we're also defining a wrapped function. When our decorator gets called, we're wrapping a function with another function. So there's two crazy steps going on before our function ever actually gets called. And what I'd like to do is collapse those into one step. So if I were to define my decorator as a subclass of my nice decorator magic thing, I'd like to be passed both my function and the arguments it's being given in one step, so I could, do stuff all in one step. That would be really cool. No idea how to do it. So I'm being passed function and my output to argument. I'm doing setup all in one step. I just, set output to something. And then later on when I get called, I can just use it. There's no craziness going on here, right? So I started writing nice decorator and I was like, well, here it is. It's simple enough. I'll just make init by default, just take a function and no arguments. I'll make call, just return the function called with the arguments it's given. And the complicated bit is still got to be in the meta class, because it's got to somehow pass me the function and the arguments it's being decorated with. So before I get to that, I'll just take a little step back and refresh what happens when you create a class. So like with my car class earlier, here I've got a class statement. It sets an attribute on a class, foo equals bar. It's got a base object. It doesn't really do anything magic. And as I alluded to earlier, that's basically equivalent to calling a meta class, passing it a name, bases, and attributes, right? So what Python is actually doing when you do that is it's calling the call method on the meta class, right? You're calling a meta class, calls metaclass.under_call, that makes sense. And it passes it the name, bases, and attributes. This is kind of not actually taken from anything in particular. I made it up. But I think it basically summarizes what Python's doing behind the scenes. It will call your Metaclass's new method. Now, we've all seen, well, some of us may have seen the new method in, normal day-to-day class object kind of stuff. New method is a class method on the meta class, and it takes some arguments and it returns a class. You can do it to, you can use it for all sorts of things. Okay, so it calls new, it gets back a class, and then it calls init. We've all used init. Init does some initialization on the class, and then it returns the class. So you can see to customize class creation, we've got 3 places we can do it. We can either do it in call, new, or init. So if you override any of those methods on a meta class, you can customize class creation. So you just have to pick the right one and go for it. Cool. So now I'll get to my nice decorator meta class. I chose to go with the call method because it's the right place to do what I needed to do. And the reason is, you can see here the new method actually has to return a class, and it's actually enforced that it returns an instance of your meta class. So if I were to create a nice decorator meta, and I wanted to customize the class creation in the new method, and I didn't want to return a nice decorator, I'd be stuffed. There's no way to do that. So I needed to do it in call. Anyway, here's my call method. It basically just does what you saw in that horrible closure thing, but it takes it out of the horrible closure thing and puts it in a meta class. So basically, I'm just detecting whether I'm being called as a factory or a normal decorator. And if I'm being called as a normal decorator, I basically just call super on my decorator, on my meta class. So I'll let the normal class creation stuff take hold here. The func is the first argument, as you'd expect with a decorator. There's no arguments, so I'll just call super and return the class. If I'm a decorator factory, I had to do something a bit more horrible. Instead of returning a class, I returned this decorator thing. And so what's happening here is I haven't yet got the function I'm going to decorate. I was just given output2 equals sys.standardout or something. So I need to return a function that will get called with the function I want to decorate. And so that's what I did here. So I haven't yet called type.call. I haven't yet called my super meta thing, superclass call method. But I do it in the decorator that I return. So this decorator will return an instance of nice decorator meta. Does that make sense? Is anyone still with me? No one's still with me? Okay.
What happens if your decorator factory takes a decorator that takes a function itself, and that you're going to hit the first one and not the second one when you want to hit the second one?
That's true. Yes, then you're screwed. I did actually work around that by allowing you to specify on your decorator class that it's always going to be a factory. This is the auto detection code, but the auto detection code will fail if your decorator wants to take one callable argument and no other arguments, because it will always go down the wrong route. But you can, yeah, I worked around that by just allowing you to have a little attribute that says, I'm always going to be a factory. I'm not going to be callable as just a decorator. Anyway, complicated. But all that complexity is now in the Metaclass on Nice Decorator. It's when you have to create a new decorator, you don't have to do any of that. Unlike the crazy closure thing. So I'd just like to say Metaclasses are not special. They're a little bit confusing, but they're not special. They don't do anything magic. They just do what every other class does, but for types instead of normal objects. They're really powerful. I like using them. I have 3 or 4 open source projects that use at least one Metaclass, one of which is really popular, Django MPTT. Use them for good, great power, great responsibility, all that kind of thing. And yeah, that's me.